Now, you sure can't help but see a system with fractions. And most of us don't care too much for fractions. So I'm going to eliminate these. But I'm going to name these equations first. Number 1 for the top one, 2 for the bottom one. Let's eliminate the fractions. So for equation 1, the LCD here between 3 and 5 is 15. So I'm going to multiply every one of those terms by 15. It'll look like this. 15 times 2/3 x plus 15 times 2/5 y equals 15 times 4. Now over here, what happens? 3 will go into 15 5 times. 5 times 2 is 10. So we'll get 10x plus, and then here, in the second term here, 5 will go into 15 3 times. 3 times 2, 6. So we'll get 6y equals 15 times 4, that's a 60. Okay, so there's our new equation 1. I'm still going to call equation 1 because it's pretty much the same as 1. Now, what about an equation 2? The LCD here is 6, right? What is the smallest number up here at the top? Both 3 and 2 and 3 divide into. It's 6. So the plan is to multiply by 6. So multiply every one of those 3 terms by 6. 6 times 1/3 x minus 6 times 1/2 y equals 6 times negative 1/3. Then we'll have what? 3 into 6 is 2. 2 times 1 is 2, so we'll get 2x minus 2 into 6 is 3. 3 times 1 is 3 times y equals, and then again, 3 into 6 is 2. 2 times negative 1 is negative 2. And that's our new version of equation 2. So now we've converted the original system to this new system, that is 10x plus 6y equals 60, right? That'll be our equation 1. And then our equation 2 is the 2x minus 3y equals negative 2. That'll be our new version of equation 2. All right, so let's do this. Let's eliminate y and get x. Focus in on the y's. The smallest number that both 6 and 3 divide into is 6. Right? I want them to be opposites. They already have opposite signs, so this will be smallest number they divide into is 6, so I want them to both be 6's. So this one, I don't have to do anything to. So the plan is just to take equation 1, but add it to what? Well, to get that to be a 6, I need to multiply it by 2. So 2 times equation 2. So let's do it. See what it looks like. So equation 1, I'll just rewrite it. 10x plus 6y equals 60. And then multiply equation 2 through by 2. Just double everything you see up there. So it'll be 4x minus 6y equals, now times 2 is negative 4. Add them together. We get 14x. 6y minus 6y is gone. This is 56. And then if you divide, x is negative 56 over 14. X is 4. Let's continue on. Let's eliminate x, and that'll get us y. So focus in on those x's. What's the smallest number they divide into? 10. I already got a 10 here, so no change there. But I do want this to be a negative, all right? I want them to be opposite. So I think what I'll do is just multiply this one by negative 5. So here's my plan. This will be negative 5 times equation 2, and then add that to equation 1. Right? It doesn't matter here. 1 or 2, 2 or 1. I'm just adding the two equations together. So I'm going to get a 10 here by multiplying by 5, but I want it to be opposite sign because they're both the same sign. So use a negative multiplier. So here's what it looks like. Negative 5 times equation 2. So I'm taking that negative 5 here, multiplying it here, here, and here. So how about negative 10x plus 15y equals positive 10. Let me just run a quick check. Negative 5 times 2 is negative 10. Negative 5 times negative 3 is positive 15. Negative 5 times negative 2 is positive 10. And then equation 1 itself, 10x plus 6y equals 60. Add those together. The x's are gone. We get 21y equals 70. Divide. Y equals 70 over 21. Well, this, of course, we can reduce, right? 7 divides each one of these. So let's write this as y equals 70 divided by 7 is 10. 21 divided by 7 is 3. So let's just summarize here. We're going to say the solution is x equals 4 and y equals 10/3. But we could also write it as an ordered pair, 4 and 10/3. And what we're saying here is that if back at the original, way up here on the left, if we were to graph this line and this line, they would intersect to the right, from the origin to the right 4, up about 3 1/3.